In the silence of deep space, a titan stirs. Andromeda, our nearest galactic neighbor 2.5 million light-years away, has long symbolized cosmic serenity, but that silence may be an illusion. On January 16, 2025, the Hubble Space Telescope revealed the most detailed image ever of Andromeda, exposing a record of cosmic trauma. Rings from ancient collisions, streams of shredded galaxies, and a fiercely burning core suggest a violent history that redefines Andromeda's past and hints at our uncertain future. Share this video on X, Facebook, Reddit, or your chats. You're the reason these mysteries keep moving forward. Thank you. The image, if printed at full resolution, would span nearly 80 meters, showing over 100 million stars. But this is no tranquil starscape. The mosaic captures the aftermath of galactic cannibalism, with smaller galaxies reduced to ghostly streaks, their stars absorbed into Andromeda's spiral arms. Andromeda's core is a furnace where stars are born and die rapidly, and supernovae forge heavy elements. Beyond gravitational pull, a halo of dark matter extends past Andromeda's visible edge, binding it together and setting the stage for future collisions. Andromeda is on a collision course with our Milky Way, hurtling toward us at over 100 kilometers per second. In roughly 4.5 billion years, the two spirals will merge, reshaping the night sky and altering the fate of every star and planet within them. Will Earth survive this cosmic collision? While individual stars are unlikely to collide, gravitational upheaval could disrupt orbits or expose planets to deadly radiation. Andromeda, once a symbol of distant beauty, now looms as a harbinger of chaos, a reminder that even the heavens are subject to change. The image from Hubble is more than a photograph. It is a prophecy, revealing Andromeda as a dynamic, evolving system shaped by forces both seen and unseen. As we gaze upon its light, we glimpse not just the past, but our own future. Andromeda is coming, and with it, a new chapter in the story of our cosmos. Section 1. The Unsettling Portrait. What if the most beautiful thing in the universe is also the most dangerous? The Hubble Space Telescope has given us a portrait of Andromeda so detailed, it feels almost alive. Stretching across 2.5 billion pixels, the mosaic captures 200 million individual stars, an unprecedented feat, like counting grains of sand on a cosmic beach. But this isn't just a snapshot of a distant galaxy. It's a record of violence. Rings, streams, and scars all testify to a history of collisions and upheaval. Andromeda's tilted disk, glowing brightly on one side and disturbed on the other, tells a story of cosmic trauma, one we're only now beginning to understand. For years, astronomers believed Andromeda was drifting peacefully towards the Milky Way, a serene spiral on a collision course spanning billions of years. But Hubble's image challenges everything. The galaxy's structure is anything but peaceful. Massive rings embedded in its disk, one 10 kiloparsecs from the core, another buried deeper, are not decorative features. They are shock waves, fossilized ripples from an ancient impact. The outer ring glows with blue, metal-rich stars, hotter and younger than their surroundings. The inner ring, a dusty structure revealed only by infrared light, was once mistaken for a mini-spiral. Together they expose a narrative of collision and chaos. The outer ring's vibrant blue stars, numbering in the millions, are a stark contrast to the older, redder stars, that dominate Andromeda's central regions. These young stars, born in the aftermath of the collision, are a testament to the galaxy's resilience and its ability to regenerate itself. Yet their presence also underscores the violence of the event that gave them life. The collision likely occurred around 800 million years ago, when a smaller galaxy, possibly the remnant of a dwarf galaxy, plunged into Andromeda's disk. The impact sent shockwaves rippling through the galaxy, compressing gas clouds and triggering a burst of star formation. Observation: the outer ring's blue stars are not evenly distributed. Instead, they cluster in dense knots, like diamonds scattered along a cosmic necklace. These clusters, known as beads on a string, are thought to form as gas and dust are compressed by the shockwave, creating pockets of intense star formation. But the real question is this: if a galaxy as massive as Andromeda can be reshaped so dramatically by smaller companions, what else lies hidden beneath its luminous surface? The answer may lie in the faint, ghostly streams of stars that crisscross the galaxy's halo. These streams are the remnants of smaller galaxies that Andromeda has devoured over billions of years. At least 15 such streams have been identified, each one a graveyard of a once independent galaxy. The largest of these, the giant stellar stream, stretches across more than 400,000 light-years and is the remnant of a galaxy that Andromeda consumed around 2 billion years ago. Speculation: could Andromeda's future hold more such encounters? Its trajectory toward the Milky Way suggests an inevitable collision in about 4.5 billion years. When these two titanic galaxies merge, the resulting galaxy, dubbed Milkomeda by astronomers, will be a chaotic, elliptical galaxy unlike either of its spiral progenitors. The collision will trigger yet another burst of star formation, illuminating the cosmos with the light of millions of new stars. The portrait of Andromeda is not just a snapshot of a distant galaxy, but a window into the universe's violent past and future. It reveals the cosmos as a place of constant change, where galaxies are born, collide, and die in an endless dance of creation and destruction. Andromeda, once seen as a peaceful spiral, now stands as a testament to the chaos that underpins the universe. Its beauty is not serene, but fierce, a reminder that even the most majestic structures in the cosmos are shaped by violence and upheaval. Section 2, Ripples of the Past. Can a galaxy remember its scars? Andromeda's rings are not mere curiosities, but echoes of ancient violence. Simulations suggest they formed when Messier 32, a dwarf galaxy, collided with Andromeda's disk around 210 million years ago. The impact left ripples still visible today, like a stone tossed into a cosmic pond. Even a hole in the outer ring matches Hubble's observations, a testament to the precision of these models. These rings are Andromeda's voice across time, whispering of the violence it endured. The collision's ripple effect is evident in the distorted shapes of Andromeda's spiral arms, which still bear the faint imprint of gravitational disruption. The collision scale is staggering. Messier 32, though now small, was once far more massive. Its plunge through Andromeda's disk released energy equivalent to countless supernovae, triggering starbursts that still linger. Some of these stars, born in chaos, now form part of the rings, their light a faint echo of their violent origin. Beyond the rings lies an older story, the giant southern stream stretching 150 kiloparsecs into Andromeda's halo. This stream is the shredded remains of a galaxy torn apart by Andromeda's gravity. Its cold, metal-rich stars glide along gravitational rails, hinting at a monumental merger. In 2018, simulations identified the culprit, M32P, a once mighty galaxy that merged with the Andromeda between 5 and 2 billion years ago. This collision formed nearly 20% of Andromeda's current stars, explaining its unusually large population of intermediate-age stars. The stream's stars bear the chemical signature of their former home, a relic of a galaxy that no longer exists. The merger with M32P reshaped Andromeda dramatically. Its halo, once pristine, is now streaked with tidal streams and shells, debris from past encounters. The gravitational tug-of-war ignited new waves of star formation and altered stellar orbits, slowly merging the two galaxies into one. The aftermath is written in the stars, their orbits and compositions testifying to the upheaval they endured. What seemed a peaceful galaxy is anything but. If Andromeda's past is marked by such events, its future may be equally dramatic. As it hurtles toward the Milky Way at over 100 kilometers per second, Andromeda is on a collision course that will reshape both galaxies. In about 4.5 billion years, they will begin to merge, their stars intermingling in a cosmic dance lasting eons. The resulting galaxy, Milky, will be a new titan in the local group, its structure shaped by violent mergers. Observation: Andromeda's faint, ghostly rings are more than curiosities. They are windows into its violent history. By studying these structures, astronomers can piece together the story of ancient collisions that shaped Andromeda. Interpretation: the rings and streams reveal a galaxy profoundly shaped by interactions with others. These encounters have left indelible marks on Andromeda's structure, from warped spiral arms to a tidally disrupted halo. Its past is a tale of cosmic violence, one that continues as it moves toward its inevitable collision with the Milky Way. Speculation: if Andromeda's past is any indication, its future merger with the Milky Way will be a spectacle of cosmic proportions. The collision will reshape both galaxies, forging a new structure from their combined stars and gas. Milky will bear the scars of this merger for billions of years, its structure a testament to the violent dance of galaxies that created it. As we peer into Andromeda's past, we glimpse our own galaxy's future, a future defined by collision, chaos, and rebirth. Section 3. The Uncertain Fate. What if our cosmic destiny is no longer certain? For decades, astronomers predicted Andromeda was on a collision course with the Milky Way, expected to hit in 4 billion years. This was based on observations of Andromeda's blue shift, indicating its approach. However, recent advancements in astrometry and modelling have challenged this fate. Astronomers now grapple with the possibility that Andromeda's trajectory might not be as straightforward as once believed. New Hubble data and measurements of 55 Cepheid variables in Andromeda have refined its distance to 2.5 million light-years with unprecedented accuracy. A 2025 study led by Til Sawala now gives only a 50% chance of collision in the next 10 billion years. Our cosmic fate is far less certain than previously believed. The Milky Way and Andromeda, once thought to be inexorably drawn together, now appear to be players in a more complex gravitational dance, influenced by unseen forces and smaller galactic neighbours. Sawala's team used advanced simulations to account for gravitational interactions between the Milky Way, Andromeda, and smaller galaxies in the local group. Data from the Gaia spacecraft, which mapped over 1.8 billion stars, was incorporated. The results suggest Andromeda's trajectory may be influenced by overlooked factors like dark matter distribution and gravitational tug-of-war, revealing a cosmic ballet where even the smallest perturbations could alter the outcome. The galaxies may merge into Milky or slide past each other, distorting both into elongated streams. Even a near miss has dramatic implications, as tidal forces could rip apart star clusters, igniting new star formation or flinging solar systems into intergalactic space. This event, unfolding over millions of years, would transform the night sky as seen from Earth, with Andromeda looming large and distorted. The Hubble image reveals the present so clearly that models predicting our fate have shifted dramatically. Andromeda's turbulent history of past interactions with smaller galaxies is evident in its halo. Its approach toward the Milky Way, whether leading to collision or a near miss, is another chapter in its violent cosmic narrative. Observation. The uncertainty of Andromeda's trajectory underscores the limitations of current models and the need for ongoing observation. As telescopes and simulations improve, astronomers may uncover new details about dark matter's distribution, refining their predictions and offering glimpses into the unseen forces shaping the cosmos. Speculation: if Andromeda and the Milky Way collide, the merger could create a supergalaxy, Milky. This event would unfold over billions of years, allowing life on Earth, if it still exists, time to adapt or escape. If the galaxies pass each other, the gravitational interaction could still reshape the local group, providing astronomers with a unique opportunity to study galactic interactions on an unprecedented scale. The aftermath would leave a legacy of new stars, displaced worlds, and reconfigured galaxies, a testament to the relentless forces of cosmic evolution. Section 4. The Hyperactive Galaxy. Section 4. The Hyperactive Galaxy. What if Andromeda is behaving like a galaxy centuries younger? Hubble's latest data reveals Andromeda's surprisingly active star-forming regions, which glow intensely against the cosmic backdrop. Unlike other massive galaxies which age slowly and predictably, Andromeda's disk is filled with hot, young blue star clusters, many forming at rates 10 times higher than in the Milky Way. These clusters, scattered in arcs and knots, defy expectations of where sustained star birth should occur. The ultraviolet light emitted by these regions paints a vivid portrait of a galaxy teeming with new life, as over 4,000 massive young stars are born within these clusters every year. This activity isn't driven by peaceful internal evolution, but by collision-induced turbulence. Past galactic collisions, such as one involving Messier 32, compressed gas clouds, triggering star formation that persists today. The collision, which occurred roughly 210 million years ago, left Andromeda with lasting structural distortions. Hubble's mosaic highlights these regions, including the Ring of Fire, a 100,000 light-year band of intense star formation. This glowing ring, shaped by ancient trauma, underscores the violence that has moulded Andromeda, with superheated gas clouds stretching across distances unimaginable to the human eye. Andromeda's hyperactive star production shows it is still reshaping itself around the scars of past impacts. Its spiral arms appear distorted and fragmented, aligned with collision trajectories, and even its central bulge shows disruption. Streams of young stars streak through it like cosmic scars. The central region, Spanning over 10,000 light-years is a chaotic mosaic of stellar streams and disrupted orbits, a testament to the lingering effects of past galactic encounters. Observation. Andromeda's disk shows asymmetric star formation, with more activity on the side facing the Milky Way. This suggests tidal forces from our galaxy are agitating Andromeda's structure, compounding the effects of past collisions. The gravitational interplay between these giants may already be shaping their evolution, despite their merger being billions of years away. The Milky Way's influence is subtle but detectable, as gravitational tugs create ripples in Andromeda's outer disk, visible in Hubble's high-resolution imagery. Speculation. If Andromeda's star formation rate continues, it could exhaust its gas supply sooner than expected, accelerating its transition into a red and dead elliptical galaxy. However, gas influx from satellite galaxies like Messier 110 and Messier 32 could delay this fate. These smaller galaxies, slowly being stripped of their gas and stars, feed Andromeda and prolong its youthful vigor. Messier 110, for example, contributes over 300 million solar masses of gas to Andromeda's reserves, ensuring the galaxy remains a vibrant stellar nursery for millions of years to come. Andromeda is not a static object, but a dynamic system still reeling from ancient traumas and bracing for future upheavals. Its story, etched into every glowing cluster and twisted spiral arm, is one of survival, resilience, and vulnerability. As astronomers study this galactic giant, they glimpse a prelude to the Milky Way's fate, a preview of the chaos and transformation awaiting our galaxy. Every new observation of Andromeda adds depth to this narrative, revealing a galaxy that refuses to succumb to cosmic entropy. As Hubble's imagery reveals Andromeda's full disk, its hyperactive nature becomes both beautiful and unsettling. Even the largest, most stable-seeming objects in the universe are subject to change. Andromeda refuses to fade quietly into old age, instead burning brightly against the cosmic tapestry, a beacon of growth and upheaval in the silent expanse of space. Its blue star clusters, visible even from Earth with modest telescopes, serve as reminders of the constant, relentless forces shaping the cosmos. Section 5. The Dynamic Core. What if Andromeda's heart is still beating with the echoes of ancient collisions? Andromeda's nucleus is so intense that even the Hubble Space Telescope, with its 2.4-meter mirror and orbit high above Earth's atmosphere, struggles to resolve its details. This brightness is not just the light of countless stars, but the product of an overdense nuclear bulge, a structure so massive and luminous that it defies conventional galaxy formation models. Sprawling and asymmetric, the bulge stretches over 2,000 light-years, twice the size predicted by theory. It is a chaotic mix of stars, gas, and dust, with stellar populations varying in age from mere millions to over 10 billion years old. This disorder points to at least one significant merger that disrupted Andromeda's core, leaving behind a swirling graveyard of stellar remnants. Evidence of these mergers lies deep within the nucleus, where remnants of cannibalized galaxies linger like specters. These ghostly relics, detectable through variations in stellar velocities and compositions, suggest a violent history. Around 8 billion years ago, a dwarf galaxy collision likely sent shockwaves through the core, igniting starbursts that persisted for millions of years. These starbursts, capable of forming stars at rates hundreds of times faster than in the Milky Way, would have lit up the core with intense ultraviolet radiation. Today, dense star clusters and irregular dust lanes still bear witness to this event, their twisted structures mapping the gravitational scars left behind. The alignment of the bulge, inner dust structures, and remnants of the southern stream reveals a galaxy whose core has been repeatedly stirred and reshaped. Andromeda's nucleus is not stable but dynamic, evolving and still responding to gravitational disturbances from billions of years ago. Ongoing interactions with satellite galaxies like M32 and NGC 205 further fuel this chaos, as their stars and gas are torn apart and absorbed into the core. M32, for instance, is believed to have been stripped of over 50% of its original mass, its stolen material now intertwined with Andromeda's core. An active core has profound implications for Andromeda. It can trigger starburst episodes, altering the galaxy's chemistry and luminosity and disrupt the orbits of millions of stars. Most ominously, it can feed the central supermassive black hole, a dormant giant 140 million times the mass of our Sun. When activated, the black hole releases energy equivalent to the output of billions of stars, heating surrounding gas to temperatures exceeding 10 million degrees Celsius. This heat drives powerful outflows that suppress future star formation, shaping the galaxy's fate for eons to come. This unpredictable nucleus serves as a warning for any galaxy destined to encounter it, including the Milky Way. In 4.5 billion years, our galaxy and Andromeda will collide, forming Milkomeda. The merger's violence will depend on Andromeda's core. If still dynamic and unstable, the collision could be catastrophic, reshaping the future of our cosmic neighborhood. Understanding Andromeda's core today offers a glimpse into this future, where the fates of trillions of stars hang in the balance. Observation: Hubble's imaging has revealed faint tidal streams in Andromeda's core, remnants of past mergers still influencing its structure. These streams, some as narrow as 100 light-years wide, stretch for thousands of light-years, tracing the paths of long-dead galaxies. Speculation: If Andromeda's core remains active during its collision with the Milky Way, the merger could trigger an unprecedented starburst, fundamentally altering galactic evolution in the local group. The resulting galaxy, Milkomeda, could shine with the brilliance of a quasar, outshining the combined light of both progenitor galaxies for millions of years. Section 6. Ghosts in the Halo. What if the halo of Andromeda is a graveyard of galaxies? Beyond the luminous disk, Hubble's data reveals something almost ghost-like. Faint stellar streams woven into Andromeda's outer halo, stretching tens of thousands of light-years into the void. These streams are the fossil record of a violent cosmic past. Shredded dwarf galaxies, disrupted star clusters, tidal arcs left behind like chalk marks after a cosmic collision. Several of these structures are so diffuse that they were invisible before Hubble's new ultra-wide mosaic. But once resolved, they reveal a pattern. The halo of Andromeda is not smooth but layered, irregular, and textured by dozens of past interactions. Some streams loop gracefully, glowing faintly with the remnants of stars torn from their original orbits. Others tear off abruptly, their jagged edges marking where gravitational forces rip them apart. Some align with the orbit of Messier 32, a nearby dwarf elliptical galaxy, suggesting a recent interaction. Others seem to originate from collisions far older, their stars now scattered like cosmic debris across the halo. The metallicity of these stars exposes their origins. Some come from primitive dwarf galaxies, their stars forged from pristine gas clouds in the early universe. Others resemble material from much larger, more evolved systems, their stars enriched with heavier elements like iron and magnesium. This patchwork halo isn't just a relic. It is a roadmap of every galaxy Andromeda has consumed over billions of years. Astronomers have identified at least 15 distinct stellar streams, each a testament to a past merger. The faint, reddish glow of some streams suggests they are composed of older, cooler stars, while brighter, bluer streams hint at more recent encounters. If its halo holds this many signatures of past destruction, then the number of mergers required to produce such complexity is far higher than previously believed. In short, Andromeda has not simply grown. It has devoured its surroundings again and again. And Hubble has just shown us the evidence. The sheer scale of these interactions is staggering. Some stellar streams stretch over 100,000 light-years, longer than the entire diameter of the Milky Way. The largest stream, known as the Giant Stellar Stream, contains over 300 million stars, the remnants of a galaxy that Andromeda consumed roughly 2 billion years ago. This stream alone accounts for nearly 10% of the halo's total stellar mass. As these streams crisscross and overlap, they create a web of light that tells a story of cosmic cannibalism. Each collision would have lasted millions of years, gradually stripping stars and gas from the smaller galaxy, until only a faint remnant remained. The gravitational tug-of-war between Andromeda and its victims has left deep scars in the halo, visible only through the most sensitive telescopes. Observation. The Giant Stellar Stream is particularly significant because it suggests Andromeda's last major merger occurred relatively recently in cosmic terms. The stream's sharp edges and distinct loops indicate that the disruption is still ongoing, with stars continuing to be pulled apart by Andromeda's gravity. This process is not just a historical event, but an active one, shaping the galaxy's structure even today. Speculation. If Andromeda's halo is this dynamic, what does it tell us about the future of our own Milky Way? As the two galaxies hurtle toward each other at 110 kilometers per second, will the Milky Way's halo one day bear similar scars? The inevitable collision, projected to occur in about 4.5 billion years, will likely result in a new, even more massive elliptical galaxy. The faint, ghostly streams we see in Andromeda's halo may be a preview of the Milky Way's fate, a cosmic graveyard yet to be written. Section 7. The catastrophic event. What if one collision changed Andromeda forever? The most striking revelation from new Hubble imagery is that many of Andromeda's defining features, its asymmetric disk, off-center rings, scattered star-forming regions, and oversized bulge, can be traced to a single catastrophic event. Simulations suggest that a massive progenitor galaxy, M32T, collided with Andromeda roughly 2 billion years ago, radically altering its structure. This impact explains the galaxy's lopsided disk, the giant southern stream stretching over 150,000 light-years, and the unexpected youth of many stars. Even today, remnants of this collision are visible, including the dwarf galaxy Messier 32, which may be the stripped core of M32P, orbiting Andromeda like a ghostly echo of its chaotic past. Andromeda is not just a galaxy of occasional minor mergers. It is a survivor of a titanic collision that fundamentally reshaped its identity. The event likely triggered a massive burst of star formation, with billions of new stars igniting in the aftermath. These young stars, scattered across Andromeda's disk, are a testament to the violence of the encounter. The galaxy rebuilt itself, forming new structures and a new dynamical balance. The collision may have also ejected vast streams of gas and dust into intergalactic space, altering the trajectory of nearby dwarf galaxies and leaving Andromeda's gravitational influence permanently changed. Observation: the aftermath of the collision is still visible today. The giant southern stream, a luminous arc of stars torn from Andromeda's disk, glows faintly against the cosmic backdrop. This stream, first observed in the early 2000s, is one of many tidal features that reveal Andromeda's turbulent past. Recent surveys have also identified shells of stars rippling through the galaxy's halo, further evidence of the cataclysmic encounter. These structures provide a fossil record of the event, allowing astronomers to piece together Andromeda's reconstruction. Speculation: if Andromeda could be so violently reshaped by a single encounter, our assumptions about the stability of galaxies must be re-evaluated. Even the Milky Way, often regarded as a quiet, stable spiral galaxy, bears scars of past interactions. The Sagittarius dwarf galaxy, for example, is currently being torn apart by the Milky Way's gravity, leaving streams of stars across the sky. Could the Milky Way have experienced a similar catastrophic event in its distant past? The answer may lie in the faint remnants of long-dead galaxies hidden in the halo, waiting to be uncovered. Andromeda's story challenges the traditional view of galaxies as slowly evolving structures. Instead, it reveals a universe where dramatic events can reshape entire systems in a cosmic instant. As astronomers continue to study Andromeda and other galaxies, they are uncovering a tapestry of collisions, mergers, and transformations that define the cosmos. Section 8. The Warped Disk. What if Andromeda's edges are still trembling from ancient trauma? One of the subtlest yet most revealing elements in the Hubble mosaic is the warped shape of Andromeda's outer disk. Unlike the Milky Way's clean spiral, Andromeda's edge bends and twists, defying normal galactic evolution. These distortions are not random. They are gravitational fingerprints, often emerging when a galaxy interacts with something massive enough to torque its outer regions. Andromeda's southern side appears pulled downward, while the northern side arcs upward, creating a wing-like asymmetry visible only in ultra-deep imaging. The warp extends roughly 32,000 light-years from the galactic center, dwarfing the distance between the Sun and the Milky Way's center, which is a mere 27,000 light-years. This warping is not static. It is a slow, dynamic process, with stars at the outer edges moving at velocities altered by millions of years of gravitational disruption. This is not the structure of a calm, isolated galaxy. It is the lingering consequence of ancient collisions, reshaping the disk long after the intruders have vanished or been absorbed. The warp suggests Andromeda has not finished settling. Its outer stars still drift along distorted gravitational contours carved by past mergers. Observations point to a significant merger event roughly 3 billion years ago, when a smaller galaxy plunged through Andromeda's disk, permanently altering it. This event likely triggered shockwaves of star formation, briefly illuminating the galaxy with bursts of light from newly born stars before the warp suppressed further stellar birth. The warp is not merely cosmetic, it has profound implications for Andromeda's stars and gas. Stars in warped regions follow tilted orbits, creating complex three-dimensional motion. This misalignment disrupts star formation, suppressing it by as much as 30% in the outer disk. The warp also affects dark matter distribution, potentially stretching and deforming the dark matter halo, creating pockets of enhanced density. These dense regions may act like gravitational anchors, further complicating the motion of stars and gas clouds, and possibly explaining the uneven distribution of stellar populations in Andromeda's outer reaches. For astronomers, the warped disk raises more questions than it answers. How long will it take for Andromeda to regain equilibrium, if ever? Are the warp signs of ongoing instability or frozen relics of a chaotic past? One theory suggests that the gravitational pull of neighboring galaxies, including the Milky Way, influences Andromeda's warps. As the two galaxies hurtle towards their inevitable collision in about 4.5 billion years, their mutual gravity could amplify the warps, setting the stage for a cataclysmic merger that will reshape both galaxies. The encounter will be spectacular, with streams of stars and gas stretching hundreds of thousands of light years, glowing faintly under the intense gravitational strain. Speculation. Could the warp in Andromeda's disk serve as a preview of what will happen to the Milky Way after their collision? The Milky Way, too, will be stretched, twisted, and ultimately consumed, its spiral arms torn apart by tidal forces. Andromeda's warped disk is not just a curiosity, it is a testament to the relentless forces that shape the cosmos, where galaxies are born, collide, and die in an endless dance of creation and destruction. By studying Andromeda's distorted edges, scientists may gain insights into the future of our own galaxy, as well as the broader story of galactic evolution in the universe. Section 9. The Scattered Stars. What if Andromeda is a graveyard of worlds that no longer exist? While most galaxies exhibit a metallicity gradient, with metal-poor stars in the halo and metal-rich stars in the core, Hubble's observations of Andromeda reveal a puzzling anomaly. Metal-rich stars, gleaming with elements like iron and magnesium, are scattered across the disk and inner halo, far from their expected locations. These stars, chemically distinct from their surroundings, were likely deposited during violent tidal interactions, torn from incoming galaxies and flung across Andromeda. Imagine a slow-motion cosmic collision spanning millions of years. Andromeda, the dominant force, tears apart smaller galaxies with its gravitational pull. The remnants of these disrupted systems are entire stellar populations carrying the chemical fingerprints of their origins. Observations suggest these scattered stars match the metallicity of M32P, a suspected progenitor galaxy, reinforcing the idea that Andromeda assimilated a major galaxy and redistributed its stars. This galactic cannibalism is a fundamental process in the evolution of massive galaxies. The consequences are profound. Metal-rich clusters orbit far from Andromeda's center, like fragments of shattered civilizations. These stars are survivors of galactic collisions, bearing chemical signatures of worlds that no longer exist. Their distribution serves as a silent warning. Andromeda grows not just through star formation, but through the consumption of entire galaxies, scattering their ancient populations like relics of forgotten empires. Consider the Milky Way's future. In 4.5 billion years, our galaxy will collide with Andromeda, merging into Milkomeda. This event will scatter stars from both galaxies, blending their chemical histories. This future collision mirrors Andromeda's past, illustrating the cyclical nature of galactic evolution. Observation. The scattered metal-rich stars in Andromeda provide evidence of past galactic interactions. Their chemical compositions, particularly high concentrations of heavier elements, align with the hypothesis that they originated from a disrupted galaxy like M32P. Interpretation. Andromeda's scattered stars suggest multiple mergers and tidal interactions over its lifespan. Each interaction leaves a distinct imprint on the galaxy's structure, influencing its stellar populations and ongoing evolution. Speculation. If Andromeda's scattered stars are remnants of consumed galaxies, what will happen to the Milky Way? As we approach our collision with Andromeda, will our stars become the next scattered relics? The answer lies in the distant future, but the clues are already written in the stars of Andromeda, a cosmic graveyard of worlds long gone. Section 10. The Deadly Choreography. What if Andromeda's satellites are dancing towards their doom? Andromeda's satellite galaxies display unusual alignment and motion, revealing another aspect of its cosmic violence. Unlike the Milky Way's chaotic satellites, many of Andromeda's dwarf galaxies form a vast rotating plane, a cosmic sheet orbiting in synchronized motion. New Hubble data shows Andromeda absorbing galaxies that once orbited in aligned trajectories, with survivors still trapped in its gravitational field. This cosmic ballet unfolds against relentless gravitational forces, with faint dwarf galaxies tracing arcs like celestial brushstrokes, slowly bending to Andromeda's will. The scale of this cosmic dance is staggering. 15 of Andromeda's 28 known satellite galaxies are aligned within a plane extending over 1 million light-years, yet just 30,000 light-years thick. These galaxies share a common rotational direction, defying expectations of random accretion and hinting at an organized capture process. The precision of this alignment is astonishing. If scaled down to human size, it would be narrower than a sheet of paper. This delicate structure persists despite the universe's chaos, a testament to Andromeda's enduring gravitational influence. This orbital choreography is deadly. Dwarf galaxies move in a coordinated spiral, ultimately leading many to destruction. Andromeda's satellite system is a gravitational ecosystem where smaller galaxies are slowly shepherded toward their end. Hubble's census reveals tidal streams of stars ripped from their parent galaxies, glowing like cosmic wounds. These streams stretch across hundreds of thousands of light-years, shimmering remnants of galaxies that once orbited freely but now exist only as fragmented echoes. The evidence lies in the stars. Spectroscopic analysis shows that many dwarf satellites contain stellar populations chemically similar to Andromeda's outer halo, suggesting partial cannibalization. Simulations predict several dwarfs will merge with Andromeda in the next few billion years. Some, like NGC 205, are already distorted by Andromeda's tidal forces, their shapes stretched into elongated arcs. Their light reaches us after a journey of 2.5 million years, a silent cry for help across cosmic distances. Andromeda's appetite is relentless. It reshapes its surroundings, preparing for future mergers. One future victim is the Triangulum Galaxy, M33, which will fall into Andromeda's grasp in about 2.5 billion years. Even the Milky Way is not immune. Andromeda and the Milky Way are hurtling toward each other at 100 kilometers per second, destined to merge in roughly 4.5 billion years, forming Milkomeda. When this collision occurs, the night sky will transform, with Andromeda's light growing brighter than the full moon, casting shadows on Earth before the two galaxies entwine in a cataclysmic embrace. Observation. The alignment and coherence of Andromeda's satellites suggest a highly organized gravitational system, challenging traditional chaotic galaxy formation models. This alignment is so precise that it has been compared to the ordered motion of planets in a solar system. Interpretation. Andromeda's past mergers shaped its structure, but future mergers, including the inevitable collision with the Milky Way, will redefine the local group. This collision will not only reshape the galaxies involved, but also alter the gravitational dynamics of the entire local group, affecting even distant galaxies. Speculation. The synchronized orbits of Andromeda's satellites may hint at an underlying cosmic mechanism governing galaxy interactions on scales larger than currently understood. As telescopes like the James Webb Space Telescope probe deeper, answers may soon emerge. Some theories suggest that dark matter filaments or unseen gravitational forces could be guiding these satellites, adding another layer of mystery to Andromeda's deadly choreography. Section 11. The Sleeping Beast. What if Andromeda's core is not dormant, but merely sleeping? Hubble's ultra-deep imaging reveals a diffuse glow in Andromeda's inner halo, initially thought to be starlight. However, spectral analysis suggests it is an ancient light echo from a powerful event at the galaxy's core, indicating episodic activity driven by its central black hole. During active phases, the black hole consumes gas and ejects high-energy radiation, scattering off dust and gas to create a faint, lingering halo. This halo, spanning thousands of light-years, testifies to Andromeda's turbulent history. This light echo acts as a time capsule, preserving evidence of a cataclysmic event tens of thousands of years ago. While such phenomena have been observed in the Milky Way, Andromeda's scale is unprecedented. A single outburst could unleash energy equivalent to 10 billion suns, ionizing vast gas regions that glow vividly in ultraviolet light. These remnants remain visible today, etched into the faint halo, a ghostly reminder of Andromeda's tumultuous past. Chandra X-ray observatory data reveals persistent X-ray emissions from Andromeda's core, signaling ongoing black hole activity. Estimated at 140 million solar masses, the black hole is in a state of low-level accretion, consuming matter and producing weak radiation. This subtle process may foreshadow a major outburst, with profound consequences for the galaxy. The faint X-ray emissions hint at the black hole's restless slumber, a quiet prelude to its potential awakening. If Andromeda's black hole fully awakens, high-energy plasma jets could disrupt star formation and alter the galaxy's structure. Intense radiation would create vast ionized regions glowing brightly as active galactic nuclei, AGN, among the brightest objects in the universe. While the Milky Way's black hole, Sagittarius A*, has shown episodic activity, its 4 million solar masses are dwarfed by Andromeda's central giant, underscoring the staggering scale of its neighbor's potential fury. Speculation. Andromeda's black hole reawakening raises questions about the Milky Way's future. In 4.5 billion years, the two galaxies will collide, forming Milkomeda. If Andromeda's black hole remains active, the merger could trigger intense activity, with the supermassive black holes spiraling toward each other, fueling violent outbursts and reshaping the galaxies. This cosmic dance could birth a new galactic nucleus, blazing with energy and reshaping the local universe for billions of years. The faint glow of Andromeda's light echo hints at its powerful past and potential future turmoil. As astronomers study this feature, they may uncover more about Andromeda's black hole and its role in galactic evolution. Every flicker of X-ray light, every ghostly ripple in the halo, brings us closer to understanding the cosmic drama unfolding in the depths of Andromeda. Section 12. The Mirror of Our Fate. What if Andromeda is showing us the true nature of galaxies? In the end, the new Hubble image of Andromeda is far more than a scientific achievement. It is a revelation, a warning, a message written across millions of stars and fossilized in the scars of ancient collisions. For the first time, we see our neighboring giant not as a serene spiral drifting quietly through space, but as a survivor of unimaginable violence, warped by past impacts, rebuilt by tidal upheavals, reshaped by the galaxies it consumed, and still echoing with the memory of a core that once burned far brighter than it does today. The image captures the ghostly remnants of at least two significant galactic mergers in Andromeda's past, events that would have released energies equivalent to billions of supernovae, tearing apart entire star systems and flinging debris into intergalactic space. These remnants now form the faint, wispy streams of stars that orbit Andromeda's halo, like spectral echoes of its violent history. The rings carved by catastrophic collisions, the shredded remains of galaxies embedded in the halo, the oversized bulge glowing like a lantern in the darkness, the metal-rich stars scattered where they should never exist, the distorted disks still trembling from old trauma. All of it paints a portrait of a galaxy that has lived through chaos we can barely comprehend. The rings, for instance, are not merely decorative features, they are the direct result of gravitational disruptions caused by the cannibalization of smaller galaxies, events that occurred as recently as 800 million years ago. These collisions not only deformed Andromeda's structure but also triggered bursts of star formation, creating regions of intense stellar activity that continue to burn brightly today. The halo itself, once thought to be a diffuse cloud of older stars, is now revealed to be a graveyard of consumed galaxies, their remnants stretched and twisted by Andromeda's immense gravitational pull. And yet, the most unsettling truth is what this image implies about our own future. Andromeda's history is not just its own. It is a mirror held up to the Milky Way, a reminder that galaxies grow not through quiet evolution, but through destruction and assimilation. A reminder that nothing in the universe stays untouched forever. Our own galaxy bears the scars of past encounters, from the disrupted streams of the Sagittarius dwarf galaxy to the mysterious Gaia-Enceladus merger event, which occurred some 10 billion years ago and dramatically altered the Milky Way's structure. These events show that galaxies are not static objects, but dynamic, ever-changing systems shaped by the ceaseless dance of gravity and matter. Andromeda's story is not unique. It is the universal narrative of galactic existence, one that the Milky Way shares in both its past and its future. And now, with new measurements showing an unpredictable fate for our two galaxies, half a chance of collision, half a chance of a near miss that could be just as devastating, we must confront the reality that our cosmic future is far less stable than we once believed. The terrifying signal Hubble received from Andromeda was not a sound, not a transmission. It was the galaxy itself, a visual record of everything it has endured